Hi dear friends, welcome to our channel Infinity Learn Mathematics in a Simple Way. In this video, we are going to discuss the very important concept of second PUC annual examination, that is properties of definite integral, that will be asked in the part E, question number 46 for 6 marks. One proof and problem will be fixed for annual exam in the part E. So let us first we will see which properties are very important in this video. ಪ್ರಿಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ತಮಗೆಲ್ಲರಿಗೂ ನಮ್ಮ ಇನ್ಫಿನಿಟಿ ಕ್ಲಾಸಸ್ಗೆ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತಾ ಈ ವಿಡಿಯೋನಲ್ಲಿ ನಾವು ಏನು ಮಾಡ್ತಿದ್ದಪ್ಪ ಅಂತಂದರೆ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಡೆಫಿನೈಟ್ ಇಂಟಿಗ್ರಲ್ದ ಪ್ರಾಪರ್ಟೀಸನ್ನು ಯಾವ ಪ್ರಾಪರ್ಟೀಸ್ ಎಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಇದ್ದಾವೆ, ಯಾವ ಪ್ರಾಪರ್ಟೀಸ್ ಕೇಳಬಹುದು ಎಕ್ಸಾಮ್ನಲ್ಲಿ. ಇದು ಒಂದು ಪ್ರಾಪರ್ಟಿ ಏನಪ್ಪ ಅಂದರೆ ಫಿಕ್ಸ್ ಇದ್ದೇ ಇರುತ್ತೆ ಎಕ್ಸಾಮ್ನಲ್ಲಿ. ಪಾರ್ಟ್ ಇನಲ್ಲಿ ಕೇಳುವಂಥ ಪ್ರಶ್ನೆ, ಪಾರ್ಟ್ ಇ ಪ್ರಶ್ನೆ ನಂಬರ್ 26 ಪ್ರಶ್ನೆ ನಂಬರ್ 46 ಪಾರ್ಟ್ ಇ ನಲ್ಲಿ ಕೇಳುವಂಥ ಪ್ರಶ್ನೆ 6 ಅಂಕಗಳಿಗೆ. ಸೊ ಲೆಟ್ ಅಸ್ ಸಿ ದ ಇಂಟ್ರೊಡಕ್ಷನ್ ಆಫ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ definite integral. Only we are just seeing the introduction part in this video, that is related to the exercise 7.10. so one property will be asked and the problem related to that property only for 6 marks in the part E, question number 46. ಅಂದ್ರೆ ಒಂದು ಪ್ರಶ್ನೆ, ಒಂದು ಪ್ರಾಪರ್ಟಿ ಪ್ರೂಫ್ ಮಾಡಬೇಕು. ಆ ಪ್ರಾಪರ್ಟಿಗೆ ಸಂಬಂಧಪಡುವಂತಹ ಏನಪ್ಪ ಅಂದರೆ ಸಂಬಂಧಿಸಿದ ಒಂದು ಸಮಸ್ಯೆಯನ್ನು ನೀಡ್ತಾರೆ ಎನ್ಯುವಲ್ ಎಕ್ಸಾಮ್ನಲ್ಲಿ. ಅದನ್ನು ನಾವು ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ಅದು 6 ಅಂಕಗಳಿಗೆ ಕೇಳ್ತಾರೆ ಇನ್ ದ ಪಾರ್ಟ್ ಇ. ಎಲ್ಲಿ ಬರುತ್ತಪ್ಪ ಅಂದರೆ ಪಾರ್ಟ್ ಇ ಪ್ರಶ್ನೆ ನಂಬರ್ 46ನಲ್ಲಿ ಬರುತ್ತದೆ. So see the first property, that is A to B. It is not the important one property, that is first one. So it will be not asked, but it is used to prove the remaining properties. ಈ ಪ್ರಾಪರ್ಟಿ ಅಷ್ಟು ಮಹತ್ವದಾಗಿಲ್ಲಪ್ಪ, ಯಾಕಂದರೆ ಇದನ್ನು 6 ಮಾರ್ಕ್ಸಿಗೆ ಕೇಳುವಂಥ ಇದಿಲ್ಲ. ಈ ಪ್ರಾಪರ್ಟಿಯನ್ನು ನಾವು ಬೇರೆ ಪ್ರಾಪರ್ಟಿಯನ್ನು ಪ್ರೂಫ್ ಮಾಡಲು ಬಳಸುತ್ತೇವೆ. तो ये प्रॉपर्टी को हम दूसरे प्रॉपर्टी प्रूफ करने के लिए इस्तेमाल करते हैं, दैट इज P0 एंड P1. ये दोनों प्रॉपर्टी जो है उतना इंपॉर्टेंट फॉर द पॉइंट ऑफ एग्जामिनेशन. इट इज नॉट, दीज टू प्रॉपर्टीज आर नॉट इंपॉर्टेंट. सो बट दीज टू प्रॉपर्टीज वी आर यूजिंग टू प्रूव द रिमेनिंग प्रॉपर्टीज. सो लुक एट हियर, दैट इज द फर्स्ट प्रॉपर्टी, इंटीग्रेशन ऑफ a to b f of x dx is what? a to b f of t dt. So see here the variable is what? Here x is there and here it is dx. Now here it is what? T, here it is dt. So what we are doing in this property means we are changing the variable. So it is called as what? The change of variable property. ये property में हम क्या कर रहे हैं? वेरिएबल को चेंज कर रहे हैं, इसीलिए हम इसको क्या बोलते हैं? चेंज ऑफ वेरिएबल प्रॉपर्टी बोलते हैं. ये प्रॉपर्टी लो वेरिएबल चेंज मानते हुए x चेंज टू what? T. We are changing x to t, and it is dx will become what? dx is also changing here, that is dt. So it is called as what? Change of variable property. In the second property, so here integration of a to b, here a is the lower limit and b is the upper limit. A is what? Lower limit and b is what? Upper limit here. And if we interchange the lower limit and upper limit, then the sign of the integral will be changed. Integration of a to b f of x dx, integration of a to b, here integration of a to b f of x dx change to what? Integration of b to a. Here the sign is changing. See here, this is very important. Here it is plus, here it is minus. So if we interchange the limits lower to upper or upper to lower, then the sign of the integral will be changed. So this property is called as what? Change of limit property. A second property जो है यहाँ पर ಇಲ್ಲಿ ಎರಡನೇ ಪ್ರಾಪರ್ಟಿ ನಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ we are interchanging the limits. We are interchanging the limits means a to b will become what? b to a. If we interchange the limit, the sign will be changed. यहाँ पर साइन चेंज हो जाता है इंटरचेंज करने के बाद में. लिमिट्स इंटरचेंज करने के बाद में साइन राइट साइड पार्ट का जो इंटीग्रल का साइन है वो क्या होता है? माइनस माइनस रहा तो प्लस. इफ इट इज अ positive, then it will become what? Minus sign. If it is negative, then it will become what? Plus, we can say. This is also very important property that we are using to prove the remaining properties. So coming to the what? That the third property, integration of a to b f of x dx, here that is equal to integration of a to c f of x dx plus c to b f of x dx. Now what we are doing here? We are breaking the limit a to b. We are breaking the limit here a to b and taking the another limit, that is after breaking we will get the what? Another limit, that is a to c first. then C to B. So this property is also called as the breaking of limit at 3 you know. We are breaking the limit A to B, that is A to C f of x dx and C to B f of x dx. Now next property, integration of A to B f of x dx. Here x is there, here A plus B is there, A plus B minus x. So what we are doing here, we are adding lower limit and upper limit. We are adding lower limit is what here A, upper limit is what here B. The sum of lower limit and upper limit minus x. So this property is what we are using, integration of A to B f of x dx is equal to what, A to B f of A plus B minus x dx. So it is very important property. This property is already asked in the year June 2014 and 15 and July 2019. July 2019 for 6 marks. Property and problem. This property has already asked in the year June 2014, 15, July 2019 for 6 marks. And the next property is integration of P4. It is a particular case of what, P3. Sorry. It is a particular case of what, P3, P4, that is property 4, that is P4 here. Integration of 0 to A f of x dx. Here it is, x is there. Now we are doing what, A minus x dx here. A minus x dx. Now integration of 0 to A f of x dx is equal to what, 0 to A f of A minus x. Here upper limit minus x. In this property, that is P4 is a particular case of what, P3. P4 is particular case of P3. Case of P3. Means almost all same. Here we are doing A plus B minus x. Here directly we are doing what, A minus x dx. So it is also very important. It has been asked already 7 times for annual examination. 7 times. Very important property as per analysis after all the previous year examination. This property has been asked in the 7 times. This has been asked. So next P5. That is next property, integration of 0 to 2a f of x dx is nothing but 0 to a f of x dx plus 0 to a f of 2a minus x dx. So it is not that much of important. So these two properties, that is a P3 and P4, are very important properties. So moving to the what next two important properties, that is, say here, that is P6, integration of 0 to 2a, integration of 0 to 2a f of x dx is equal to. So this property has the two results, that is 2 into 0 to a f of x dx, and it is 0 here, 2 into 0 to a f of x dx if f of 2a minus x is equal to what, f of x. So here integration of 0 to 2a f of x dx is equal to what, 2 into 0 to a f of x dx, when it is will become 2 into 0 to f of x dx if f of 2a minus x is equal to what, f of x, then only it will become what, 2 into 0 to a f of x dx. If it is 0, if f of 2a minus x is equal to what, minus of f of x. So next the last property and very important property, this is also very important and very important property for the point of. So for as per analyze, after the analysis of all the previous question papers, I can say here that I will say, so this property and this property are also very important, and these two properties are also what, very important properties, and this one is very important property, very important property we can say. So see here the next one, integration of minus a to a f of x dx, integration of minus a to a f of x dx, it also has the two results, that is integration of 0 to 2 into 0 to a f of x dx, 2 into 0 to a f of x dx if f is an even function. If f is an even function, that is, if it f is an even means f of minus x is equal to what, f of x, f of minus x is equal to what, f of x. It is 0 if f is an odd function. If f is an odd, if f is an odd function means what, f of minus x is equal to what, minus f of x. f of minus. If f of minus x is equal to what? F of x means what? It is 2 into 0 to a f of x dx, and f is an what? Even function here. F is an what? Even here, and it is 0 if f is an odd function, that is f of minus x is equal to what? Minus of f of x. So these are the what? All the properties, and very important properties. Look at the first property here in this video we are going to discuss here. Just it is not important for the point of annual exam, so even though that also we will prove this one. Take the LHS first here. Integration of a to b f of x dx. Now put x is equal to t, differentiate with respect to t. Now dx by dt, derivative of x with respect to t is what? Dx by dt, and derivative of t is what? 1. Now dx is equal to what? Dt. Now write x is equal to t once again. When x is equal to a, substitute here lower limit, and when x is equal to b, the value of t will become t is equal to what? A. This implies t is equal to what? B. Now come to here, dx, this one. See here. Now the integration, what is the lower limit? If I put x is equal to a here, what I get here? T is also a. It is a. If x is equal to b, when x is equal to b, t is also what? B here. Now f of x is replaced by what? T, and dx is what? Dt. That is equal to what? RHS. Therefore we can say that integration of a to b f of x dx, integration of a to b f of x dx is equal to what? A to b f of t dt. So this property is called as what? Change of variable. You change the variable, there will be no change in the what? Integral, we can say here. So it is very easy one, and this property will not be asked for the annual exam, but this property is used to prove the remaining properties, we can say. Next, prove that. So it is also not important for the point of annual exam, but this property is also we are using to prove the remaining properties. See here. Now take this one, integration of a to b f of x dx. Now integration of f of x is what? Capital F of x, we can say here, a to b. By the fundamental principle of integral calculus, now f of first upper limit f of b minus f of a. That is integration of a to b f of x dx. Now I am writing this one in this minus f of a first, then plus f of b. Now take the minus sign common, f of a plus f of a minus f of b. Observe here, first after integration of f of x is what? Capital F of x. Now substitute the upper limit first, apply by the fundamental principle of integral calculus, second fundamental principle of theorem, fundamental theorem of integral calculus, that is f of b minus f of a. Fundamental theorem of integral calculus we are applying here. First upper limit we are substituting, then minus of the what? Lower limit, f of b minus f of a. Now I am writing minus f of a first, then plus f of b. Now take the minus sign common, f of a minus f of b, that is LHS equal to here. Now integration of a to b f of x dx it is. Now a to b f of x dx is equal to, this can be written minus, see here, this is the lower limit, lower limit will become what here? Upper limit, that is a b to a f of x dx. Hence the proof of this property, that is equal to what? RHS, we can say. Therefore we can say that integration of a to b f of x dx is equal to minus b to a f of x dx. So if you interchange the limits, the sign of the integral will be changed. If you interchange the limits, the sign of the integral will be changed. So these two properties are very important property to prove the remaining property, and these two properties will not be asked for annual examination. ಈ ಎರಡು ಪ್ರಾಪರ್ಟಿ annual examಕ್ಕೆ ಕೇಳಲ್ಲ, ಆದರೆ ಈ ಎರಡು ಪ್ರಾಪರ್ಟಿಯನ್ನು ನಾವು ಬಳಸಿಕೊಂಡು ಉಪಯೋಗಿಸಿಕೊಂಡು ಉಳಿದಂತಹ ಪ್ರಾಪರ್ಟಿಯನ್ನು ನಾವು ಏನು ಮಾಡ್ತೀವಿ ಅಂದರೆ ಪ್ರೂಫ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳಿ ಹೇಳ್ತೀವಿ ಪ್ರೂಫ್ ಮಾಡ್ತೀವಿ. So thank you so much for watching my channel. Please, still those who have not like and share my channel, please like, share and subscribe my channel. Thank you so much.